Hello friends. In the last lecture, we have discussed that what is called as graph, and we have seen certain graph types. Today, we are going to learn various graph terminologies. Now, let's go through these graph terminologies one by one. The very first thing you should know that an edge is one of the two primary units which are used to form graphs, where each graph has two ends where the vertices are connected to it. Or we can say that an edge is incident on two vertices. As you can see in the picture, there are total 5 nodes, and all these 5 nodes are connected to each other via number of edges. This type of graph used over here is an undirected graph, where an edge going from vertex 1 to 3 is equivalent to an edge going from 3 to 1. If two vertices are endpoints of the same edge, they are said to be adjacent. A vertex outgoing edges are directed edges that point to the origin. A vertex incoming edges are directed edges that point to the vertex destination. Here, the total number of edges occurring to a vertex in a graph is its degree, and the out degree of a vertex in a directed graph is the total number of outgoing edges, whereas in degree is the total number of incoming edges. A vertex with in degree of 0 is referred as source vertex, while the one with out degree 0 is known as sink vertex. There is another concept which is called as isolated vertex. An isolated vertex, the 0-degree vertex, that is not an edge endpoint. A path is a set of alternating vertices and edges with each vertex connected by an edge. The path that starts and finishes at the same vertex is known as a cycle. That means if you start from vertex 1 and if you come back to the same vertex using the various edges inciding on other adjacent vertices, that path is called as a cyclic path. A path with unique vertices is called as a simple path. For each pair of vertices x, y, a graph is strongly connected if it contains a directed path from x to y and a directed path from y to x. This type of graph is also called as strongly connected graph. A tree is a connected forest. The primary form of the tree is called a rooted tree, which is free tree. A spanning graph, subgraph, that is also known as a spanning tree. A connected component is the component is a connected component is the unconnected graph's most connected subgraph, and a bridge, which is an edge of removal, will sever the graph. Forest is nothing but a graph without side. Now let's see various type of representations of graphs. So there are two basic types. One is called as adjacency matrix and second is called as adjacency list. So as you can see on the screen, this is a graph and there is a matrix associated with it. If there is an edge going from one particular vertex to other, that edge will be represented by 1. And if there is no edge between the pair of vertices, then that will be represented by 0. So as you can see on the screen, there is A, B, C, D, E on the row side as well as A, B, C, D, E on the column side. This is 5 by 5 matrix because there are total number of 5 vertices. Now, if you look at the diagonal, okay, so for B is the exception because B has a self loop. So there is 1 from B to B edge. Otherwise, if you look at the diagonal of this matrix, you will understand that all diagonal values are 0 because there is no edge to itself in case of vertices of A, C, D, and E. But as B has a self loop, there is an edge, so it is represented as 1. So if you look at the first row, you will understand that A to A it is 0 because there is no self loop for A. A to B is represented by 1. A to C is also represented by 1. A to D is also represented by 1. And as there is no edge between A to E directly, A to E is kept as 0. Okay. So the way in which the graph is represented in the form of matrix, which shows the adjacent vertices and the edges lying between them, then this type of matrix is called as adjacency matrix. There is another example which is called as adjacency multilist. The second representation of a graph is called as adjacency multilist. Let's see that. So in case of adjacency multilist, here is the example. Here, the specific vertices are shown as a linked list. For example, this is a weighted undirected graph shown over here. If you look at the array, you can find out A is connected to B is a directed graph. Okay, A is connected to C and A is connected to B. So if you talk about A is connected to BCD via the direct links. Then B is connected to no other node because there's no outgoing arrow or outgoing edge going from node B. If you talk about C, C is again the same thing is happening with C. There is no outgoing edge. So we haven't referred anything over there. And if you talk about B, from B, there is a self loop going to itself to D to D. And then there is another outgoing edge going from D to B. Okay. So this is the way adjacency multi-list is represented. The next part over here is what are various operations we can perform on graphs. So as you can see, here, there are certain operations which are performed on graphs. One can create graph, one can insert a vertex, one can delete a vertex, one can insert an edge, or we can even delete an edge. So creating graphs will be done using two different techniques, adjacency matrix and adjacency multilist, like we talked about. The next part over here is about graph traversal algorithms. There are basically two graph traversal algorithms. First is called as BFS or breadth first search. This is a technique which is used to find a node in the graph that meets the criteria. What is the criteria over here? It begins at the root of the graph and investigates all nodes at the current depth level before moving on to nodes at the next depth level. Second, to maintain the track of the child nodes that have been encountered but not yet inspected, more memory, generally a queue, is used in this case. So if you talk about BFS, let's see a simple example of BFS so that we can understand how it works. So as you can see over here, this is a graph. We have to do it. We have to go through this level wise. So we start with visiting the first vertex here as 1. Then after visiting the first node 1, we'll visit depth wise the next node, that is vertex is 2. Then after visiting the next vertex, that is 2, we will visit to the next vertex. In this case, it is 3. We are talking about breadth first traversal. Okay. So on after visiting 1, we'll visit 2, then we'll visit 3. Then again we'll move down and then we'll visit 4, 5, 6 respectively. If you remember, we have seen in tree how to level a tree. Okay. So the same leveling of tree you can apply over here to this type of graph, which is a tree structure graph. And you can simply go visiting the vertices in a level wise manner. So the BFS answer of this is 1, 2, 3, 4, 5, 6. Okay. The next part in this case, the next type of traversal in this case is called as depth first search traversal. Okay. So in depth first search traversal, as you can see here, the criteria used over here is it traverses or explores data structures such as trees and graphs. It starts with a root node and examines each branch far as feasible before backtracking. To maintain a track of the child nodes, it makes use of a stack. So if you remember, in case of BFS, we talked about data structure queue. In case of DFS, we are going to make use of data structure stack. Let's see an example of this. So as you can see, the same tree structure graph is used over here. You have to talk about depth wise. So after visiting the very first root node, root vertex, in this case 1, we'll visit vertex 2. Then depth wise, we'll move to vertex 4. After visiting 4, we will backtrack to 2. But as 2 is already visited, we'll move on to 5. Then after visiting 5, we'll backtrack. We'll backtrack to 2, which is visited. We'll backtrack to 1, which is also visited. Then we'll visit 5. then we'll visit, sorry, after that we'll visit 3, and then finally we'll visit 6. So the DFS answer is 1, 2, 4, 5, 3, 6. And this is called as depth first search traversal of the given graph. There are certain applications of graphs we should understand, that where graphs are used. Graphs are used in computer science to depict the flow of computation. They are also used for users on Facebook to keep track of Facebook friend suggestion systems. Then it is also used for resource allocation graphs in operating systems. Web pages are referred to as vertices on the World Wide Web. So if there is a link from page A to page B, that can be represented with an H. This application is an illustration of directed graph. So this is how we have come to the end of graph part. Thank you.